In today's lesson, we're going to be learning about Pythagorean Theorem. Now, I know a lot of you are already familiar with Pythagorean Theorem. You can probably state the a squared plus b squared equals c squared. But today we're going to learn a little bit more about Pythagorean Theorem and how to use it to determine what type of triangle something is. So we're not just solving for a side, although that's one of your learning targets. You can solve for one of the sides in a right triangle. Remember, Pythagorean Theorem only works in right triangles. But then we can also use the Pythagorean theorem to determine what kind of triangle it is. Okay, whether it's a right triangle, an acute triangle, or an obtuse triangle whenever we're given some lengths of some sides. So hopefully by the end of today's lesson, you're going to be able to solve a problem that looks like this, where you're given three possible sides of a triangle, and then you can determine what kind of triangle it is. Now, first of all, before we get into Pythagorean theorem, let's make sure that we understand what makes a triangle. Okay. You're going to be given three sets of possible sides, or a set of three possible sides, and you've got to be able to determine whether or not this is indeed a triangle. Well, the rule is this, that the sum of any of the two lengths of those sides of the triangle, any two sides of the triangle, those lengths have to add up to be greater than the third side. Okay, and if you think about it for a second, let's say that we have, let's just do kind of an example here. Let's say that I have a side of 9 that's given to me, and then I have a side of 4 and a side of 3. Oops, this is a very crude drawing here. Well, notice that with these other two sides, that 4 and the 3, because they don't add up to be greater than that 9, there's no way that we can connect those to form a triangle, right? If we took this 4 side and we connected it to the 9 side here, and then we took this 3 side and we connected that to this end, there's just not enough overlap in order to make these two other sides join up. So these two sides then have to add up to a number greater than 9 in order for this to work. Okay. Now, here's a couple of examples. Let me just erase this off the screen really quickly. And here are a couple of other examples. So let's test this one out. We have three possible side lengths of 6, 7, and 10. Okay. Well, let's determine whether or not these add up. Remember, any two sides must add up to be greater than that third side in all cases. What we need to do is take all these numbers and add two of them together and make sure it's greater than the third side. So if we take the 6 and the 7, that adds up to 13, which is greater than that third side, 10. And of course, if we take any of the others, we take 6 plus 10 or 7 plus 10, those are going to be greater than the 10 as well. So really what we're looking for is those two, really what you got to pay attention to those two smallest numbers, okay? If that 6 and 7 don't add up to be greater than 10, then this cannot be a triangle. So in this case, that one is indeed a triangle, okay? In the next one here, we have three possible side lengths of 2, 4, and 6. Well, if I look at just that 2 and the 4, and I just add that 2 plus 4, well, that equals 6. Well, can that be a triangle because it equals 6? No, it's got to be greater than 6. So because this adds up to equal 6, again, it's kind of like we had a side of 6 here, we had a side of 2 here, we had a side of 4 here. But there's no way to add any angles in here when we connect this, because once we start connecting these to the ends, like we put that 2 there and we put the 4 here, well, there's going to be a gap, because once we start raising those with angles, there's no way to connect those sides because it's not long enough. So indeed, this one here is not a triangle. Okay, so just add two numbers and make sure that that's greater than the third side. Do that in all cases to determine whether or not it's a triangle. Now let's get into Pythagorean theorem. Now again, you're probably pretty familiar with this. Pythagorean theorem, you've heard the old a squared plus b squared equals c squared, okay? Well, that's because in a triangle, the sum of the two legs, the sum of the squares of the two legs is equal to the square of the hypotenuse, okay? And that's where we get the a squared plus b squared equals c squared. Notice that the a represents a leg, B represents a leg, and C represents the hypotenuse. And as we discussed in a previous lesson, The legs of the triangles are the ones that meet at the 90-degree angle. The hypotenuse is the longest side, which is across from the largest angle, that 90-degree angle. Okay. We can also use Pythagorean theorem not only to solve for sides, okay, and that's what we're going to be doing here in just a minute, but we can also use it to prove that it's a right triangle. Because again, Pythagorean theorem only works in right triangles. So if you add the squares of the two legs together and it's not equal to that hypotenuse squared, then that cannot be a right triangle. Okay, it's only when that a squared plus the b squared does indeed equal the c squared that is a right triangle. So let's do a couple examples here in a minute. But first, you may see this from time to time, a Pythagorean triple. This is not really something that's imperative for you to remember or memorize, okay? But this is something that could save you a little bit of time at some point when you're solving some problems. A Pythagorean triple, is a set of three positive integers that satisfy that Pythagorean theorem. So basically, when we take a whole number squared plus another whole number squared, it's going to equal another whole number squared. Okay, and there are certain types of these that always work out to be whole numbers, like 3, 4, and 5. If you have two legs of a triangle that are 3 and 4, well, then that hypotenuse has to be 5, because 3 squared, if we just do the math here, you got the 3 squared plus the 4 squared, which is 9 plus 16, which is 25, and the square root of 25 would be 5. But not only are all of these here at the top the triples, but any multiples of those. Remember, we have similar figures, right? If we have a right triangle with a 3, 4, and 5, and we scale that up by 2, then we've got sides of 6, 8, and 10. It's a similar figure. It's just a larger version of the original. So that is also going to work out to be whole numbers too. So when we have a 6 squared plus an 8 squared, we're always going to get 10 squared. Okay, or 9, 12, and 15. That's another common triple that you might see. But these are some of the Pythagorean triples that you might want to. Again, not important that you memorize these, but it's something good to know, and it could save you a little bit of time. So have 5, 12, and 13 in those multiples, 8, 15, and 17. Remember, the hypotenuse is the biggest side, right? It's the longest side, so it's going to be that largest number. And then 7, 24, and 25, and there's probably a couple others, but again, not too important to memorize. But you may be asked if something creates a Pythagorean triple, and it only does that when you get whole numbers as your values for A, B, and C. Okay. So let's do a couple examples here where we're solving for a side, and we're using Pythagorean theorem again. It's a squared plus b squared equals c squared. Remember, c always represents the hypotenuse. Okay, you can't change that. Okay, I know some of the tendency sometimes, especially if you're solving for a side, is to just put the two numbers that you have on this side of the equation over here, and then solve for c squared. It doesn't work that way. It's always the hypotenuse is represented by c. So this is our hypotenuse, so that's the one that we're looking for, okay? So we're just going to plug in the numbers, and this one's pretty straightforward. We would just take 7 squared plus 11 squared to equal our c squared. We have 49 plus 121. So our c squared is equal to 170. And then all we have to do is take the square root of 170, and we'll solve for the length of our side. So when we do the math, then the square root of 170 is approximately 13.04, which is the length. Oh, in this case, it's x, not c. So our x value, our hypotenuse, would be 13.04. The second one is pretty straightforward as well. We would take the 9 squared. We'll start with our theorem, though. A squared plus b squared equals c squared. One of our legs is 9. The other leg is 40, and that's going to help us find the hypotenuse. Now, again, when you're doing this, by the way, it doesn't matter, which one's A and which one's B. If they're both the legs, then they both work. So it's not a big deal. So we have 9 squared, which is 81. We have 40 squared, which is 1600. Add those two together, which is 1681. Remember at the very end, that is the hypotenuse squared, which again we'll call x. And if we find the square root of 1681, then that is 41. This is one of those Pythagorean triples that we just talked about a minute ago, where everything works out to be a whole number. You have a whole number of 9 or an integer. You have a 40, which is a whole value. And then our hypotenuse works out to be 41. Now, when you're solving these, make sure you're checking for reasonableness too, okay? Remember that hypotenuse has to be the longest side. So if we got a number for this x value that was not greater than that other second longest side of 40, then something would be wrong, okay? Kind of the same thing that we did in the first problem over here. If we got something that was less than 11, then something is off with our math, okay? So we got to make sure that that is the longest side. And conversely, when we look at a problem like this third example over here, we're solving for one of the legs. So the number that we get for that value should be less than the hypotenuse, which in this case is 24. So remember, when we're setting up our Pythagorean theorem, our a squared plus b squared equals c squared, we now have the hypotenuse here. So that's got to go into our equation where c is. So, and again, it doesn't matter which one of these we use for a or b, but we're just going to plug in what we see here. Let's call it ax. So we got x squared plus b is the 9 squared equals our c value of 24 squared. And then we just start solving from there. 9 squared is 81. 24 squared is 576. Now to solve for x, we've got to get this 81. Remove that from that side by subtracting that from both sides. So x squared then would be 495. And the last step then to undo that exponent would be to take that square root. So x would be the square root of 495, which would be 22.25 roughly. No, we're not going to count off for rounding on these here. I'm rounding to the hundredths place. Again, these are never-ending decimals. Typically, when you do this, you're going to have never-ending decimals. So just round it to the second decimal place. In this case, 22.24859, and on and on and on, rounds to 22.25. Now, with Pythagorean theorem, we can also use that to determine what type of triangle it is, okay? So when you plug in the sides that you're given of a triangle and you put it into Pythagorean theorem, the a squared plus b squared equals c squared, that also tells you what kind of triangle it is, because if it doesn't work out to be the same on both sides of the equal sign, then it's not a right triangle, it's something else. It's either going to be an obtuse triangle or an acute triangle. And the way it works is if you solve for that hypotenuse, you square that hypotenuse, and that amount is less than the total of the two squared legs added together, then that means that that is an acute triangle. If that hypotenuse squared ends up being greater than the total of the other two side squareds, then that means that that is an obtuse triangle, okay? So just think about it like this. When you have a right triangle, the hypotenuse squared, that number is equal to whatever else is on the other total on the other side of the equal sign. When that number is greater, that means that that hypotenuse is getting longer, okay, which makes that angle across from it, which in a right triangle would be the 90 degrees, it makes that angle across from it get bigger. So if it's bigger than 90 degrees, then that's an obtuse angle, which makes it an obtuse triangle. If not, that's an acute triangle. So let's just plug in some numbers here and see what we think. So we've got here 9, 12, and 10. So if we use those in our Pythagorean theorem, again, we got a squared plus b squared equals c squared. Well, first of all, we got to determine which one's the hypotenuse. So which one do you think it is? Yeah, it's the biggest one. It's the 12. So 12 has to be the hypotenuse. So I've got to plug in the 9 and 10 for a and b. and I've got to use 12 for the hypotenuse. So in this case, we've got 9 squared plus our other leg squared of 10, and that's going to equal our hypotenuse squared. So all we have to do here is just solve it down and see which side of the equal sign is larger at the very end once we add those two legs together. So we got 9 squared, which is 81. We got 10 squared, which is 100. 12 squared is 144. If we add these two together on this side of the equation, we get 181. And you'll notice that the hypotenuse squared, this number, is smaller than this side over here. So that tells us then that this is an acute triangle because this number is smaller. Okay, again, that's the one that we're looking for. We're looking for the hypotenuse. How does that compare to the other side total? So when we look at 6, 10, and 8, again, this has to be our hypotenuse here in the middle because that's the longest side. You might already see that this is a right triangle because it's one of those Pythagorean triples that we talked about, that 6, 8, 10 triangle. Let's just plug in the numbers. We got a squared plus b squared equals c squared. That's our Pythagorean theorem. We'll plug in our two legs of 6 and 8 and our hypotenuse of 10. 6 squared is 36, 8 squared is 64, and 10 squared is 100. And if you'll notice, when we add the 36 and the 64 together, that amount comes out equal to the hypotenuse amount squared. So that tells us that that's a right triangle. Again, Pythagorean theorem only works in a right triangle, so that has to be a right triangle. And then we have this last one over here where it's 3, 4, and 6. And by the way, we didn't really talk about whether or not this was a triangle. But if we did take these other two, if we took the 9 plus the 10, that is greater than 12. So that's going to be a triangle. And of course, if we added all the other combinations, that would be the two that we're adding together would be greater than the third side. And we can do that for all of these three here. But this does work out to where all three of these are triangles. But this is something that you're going to have to do. You're going to have to actually add them together first. So if we take this one, for instance, 3 plus 4 is 7, which is greater than 6. Again, 6 and 4 is greater than 3. 3 plus 6 is greater than 4. So this does work out to be a triangle. So that is a triangle. And now we can try to solve for what kind of triangle it is by plugging it into our Pythagorean theorem. So a squared plus b squared equals c squared. Again, our hypotenuse is 6 because it's the longest side. So we've got 3 squared plus 4 squared and 6 squared as our total hypotenuse squared. And now we just solve. So 9 plus 16. And 9 plus 16 is 25, which is not equal to 36. So in this case, the hypotenuse squared number is greater than 25. So that tells us that that has to be an angle of greater than 90 degrees across from the hypotenuse, which makes this an obtuse triangle.